one of the interesting things about continuous functions is that even a composition of continuous functions remains continuous given a little bit of nuance. So if we have some function g and it's continuous at this point c, and we know what the value of the function is at c, so g of c equals L. So I have c, I plug it into g, I get L. And then I can determine that f is continuous at the output of that g function. Then when I do this composition, f of g of x, which I prefer this, I think this is a little more straightforward because you're saying plug it into g and then take that value and plug it into f. Then this function is continuous at the original input. Because what happens here, I didn't write this before, but what happens here is you're really saying f of g of c, right? And you're taking the limits, so it's a little more complicated than that. But this is what's being plugged in for x here. And since you know that g of c is L, and you know that f is continuous at L, then you're good. So it's this step-by-step process. You're really breaking it into sub-problems or sub-functions. And we deal with composition of functions all the time in math. We just don't usually think about them as composition. But if we do, if we try to think of it that way, let's take a look at a few examples. Like sine of 3x. Well, in this case, the 3x, and maybe it's easier to label it this way, I could say that f of x is sine of x g of x is 3x. So I'm plugging this in wherever I would see a 3x. So f of g is sine of 3x. And similarly, in this particular case, f of x is the square root of x, f of x is tangent of x, g of x is x squared plus 1, g of x is 1 over x. Now, in this particular case, the g function is continuous everywhere, right? That we know that polynomials are continuous everywhere. However, the square root of x is continuous, but only on its domain, which is 0 to infinity. So what we have to watch out for is cases where the output of this might be like a negative number. In this particular case, it isn't, because it's just a shifted parabola. So you start above the origin and just keep going. So you have no issue. So this thing is continuous on 0 to infinity. This thing's continuous everywhere. This one's a lot trickier because the tangent function is continuous except at pi over 2, 3 pi over 2, 5 pi over 2, and so on and so forth. And it technically goes in the negative direction too. And g of x is 1 over x. So if you think about the graph of 1 over x, this is just the positive version of that graph. But if that's 1, from here to here, the output of that function takes on every possible value. Or this is 1, 1. So every value bigger than 1 is technically covered, and every value less than 1 is technically covered. So the only value that doesn't come out of that 1 over x function is actually the value 0. So the reason I'm saying this is because you're going to have discontinuities here at a ton of points, and they're actually going to get clustered as you get high, because that thing starts rising so quickly as you get close to 0. It just keeps going up. So you're going to have all these discontinuity points. Boom, 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 boom. Now, between those points, it's still continuous, but those strips are going to get really thin. And as you go from here to here, you actually end up with all the outputs of 1 over x all the way out here. None of them cause any kind of discontinuity in tangent 1 over x. In this function. None of those outputs here cause issues. So, since none of those values cause, well, I'll just put it this way, because in the tangent function, this is just the first piece from negative pi over 2 to pi over 2. So notice that the point 0 to 1, which is this little strip here, the tangent function has no discontinuity, and every value from here to here is in that kind of 0 to 1 range, so the tangent function has no discontinuities there. So that one's a little more tricky. That one's a really good example of why it's good to have good graphing techniques, to use calculators, math packages, give you a better feel for that. It's good to be able to plot this stuff on your own, but sometimes it's helpful to have a little bit of technology there to lend itself to you. But anyway, the idea of continuity composed function is we want to look at the continuity of the g function and then the continuity of its context inside of the f function.